កម្មវិធីកិច្ចសន្ទនាកម្ពុជានិងពិភពលោក
Good evening, Excellency, ladies and gentlemen. Welcome once again to Cambodia Global Dialogue, Southeast Asia TV. Tonight I have the pleasure to have two good friends, older friend, long-time friend. But it's just funny that we all ex-UN retiree. I'm not retiree, but all ex-UN. Dr. Cham Bongati is from IAEA.
International Atomic Energy Agency.
Dr. May Kalyan is former FAO. I'm with the International Trade Center, UNCTAD, WTO. But we're not talking about the UN here. Tonight we are focusing on STEM, science, technology, engineering, math, and STI, science, technology, and innovation. And I want to put this into the context that the Cambodian government has the Industrial Development Policy 2015-2025. Basically, what we try to do is to transform Cambodia into a part of the regional global supply chain, moving up the industrialization of the country. So many things need to take place from the business side. But today we'll focus more, how do you prep the workforce? How do you prep the education side, so that we can produce people that can enter the workforce, but qualify with skill match with the need of the country. So for some of the speakers may have heard you before, but I think it's good that I give you anyway a few minutes each to introduce yourself. We start with you, Mang Kalyan.
I am May Kalyan. I'm a retiree, as Pian was saying, and advisor to the government.
But Supreme National Economic Council.
Yeah, to SNEC. At the same time, I'm chairman of Board of Trustee of RUPP, Royal University of Phnom Penh. Thank you.
So my name is Riti Chem. Thank you for your kind invitation. By a background, I'm a physician and specialize in radiology and nuclear medicine. But over the decades, I moved to the policy with science and technology, and I taught in different continents for almost 35 years. And currently, I'm the executive director of the Cambodia Development Resource Institute. Among our many programs, policy research, we have one particular that is of interest of tonight's show is the higher education research and vocational training policy research.
Well, thank you, Bong. It's interesting that when we speak about the industrial development policy, Bong, you and I were part of the team that conceptualize and work on the drafting and finally get to see the adoption by the government of Cambodia 2 years ago. And Bong Thi, from CDI, you're more policy monitoring, policy implementation, benchmarking, the policy side of it. So it's quite interesting that we are looking for the last 2 years what have transpired since we have the IDP in place. And I can tell you this, that before the IDP, a lot of focus in the education system was more toward the soft skill. I would say accounting, management, economics, marketing, yes, that sort of thing. Not much in science. And it's quite interesting that the last 2 years, we see even the shift of different universities toward introducing more science field in their curriculum. And even the marketplace is signaling that, I'm not going to go into a university where I'm going to take management as my major. So the marketplace is also dictating this reorientation. Right? So anyway, maybe I start with you first. From the Royal University of Phnom Penh, RUPP, what is currently your program when it relates to STEM?
Thank you, Sipana. I like to bring the overall picture first. I'm familiar with STEM, S-T-E-M, but nowadays people add another letter called A.
Which is?
A could be arts, could be agriculture.
Oh, interesting.
could be agriculture. And
so it becomes STEAM then?
STEAM, yes, yeah. STEAM or STEM, I don't know how to say, but A also, right? I think Cambodia also is very relevant to A.
Interesting.
Very relevant to A. So we should not forget A, this A, because this is a foundation of our nations.
You mean agriculture?
Agriculture.
Yes.
And then I like to say also that we have to think that STEM or STEAM, STEAM for America, STEAM Cambodia, STEAM Japan, STEAM China, all different, right? Things a few years ago, it's good that we talk about STEAM.
Yes.
STEM. It's good we're talking, so people kind of have to put our mind together on this issue. But we have to think, what is it for Cambodia? Which level we are talking about? America, they're talking about Google car without driver, for example, right?
It's fourth industrial revolution already.
It's good for them, right? But what is our target? So we have to set, the area that we're talking about. I think this is more important.
So basically, it's the same thing, but look from different angle, different need, different level of development of the country.
Right. Absolutely. Different.
All right.
Different.
All right. Well, we will get into this comparative mode later on, because I can tell you this, that China now, for example, annually produce about 4.7 million engineers, as compared far exceeding India, US even. But we'll get to that later. Bharati, what's your perspective on STEM versus STI? What's the difference?
Yeah, so first of all, I'm very pleased that Cambodia and the government of Cambodia is embarking, boosting on this STEM education. Myself, I have a career in STEM. It's an application of science, integrated with science technology applied to medicine. STEM is a kind of curriculum that integrates math, physics, chemistry in order to teach university student or high school student to integrate all this science to solve complex society faced by Cambodia, by the region and by the world. Just a few examples: global warming, for example, the problem of energy, all is about science and technology. So that's the point. And then you mentioned that there's a shortage of people educated in that. So to move in that is important. So STEM is a mindset that should support the reform of curriculum in many education system in Cambodia. High education, and also not to forget vocational training. So that's STEM. STI is an acronym for Science, Technology and Innovation. It's more like a big ecosystem and a paradigm. You mentioned the industrial development policy. There is no industrial development possible without science and technology, without engineer, without scientists. So STI is a big picture that you need a policy for the country, and is being drafted now. And I have a scoop for you, is that next week, no, actually not next week, but Friday, CDI will sign an MOU with the National Science and Technology Council from the Ministry of Planning in how CDI can contribute to this research and drafting of this STI policy to make it very relevant to the needs of Cambodia. And in the STI context, you need to educate people, train people, but more than that, you need a governance who gonna fund science and technology activities in Cambodia, and namely the specialists call that R&D, the research and development. And if you look at the global context, the two countries that are most advanced and invest most on that is Israel and Korea, more than 4% of their GDP. And then below that you have the US, about 3%. And then below that around 2 or a little bit below 2 is the EU and China. In Cambodia we are very low, and it's not surprising, but at least if we are aware that we should invest in R&D. But the fundamental is that in order to boost the industrial development, particularly you mentioned rightly Industrial 4.0, which is the introduction of digitization, robotization in the manufacturing. We need this to upgrade these skills. So that's about the SDR. So you need governance. Many things must be done at the same time. Yeah, the whole ecosystem.
But Mukhalyan, I think I really appreciate the fact that you try to bring some fundamental in the Cambodian economy, which is agriculture. Of course, we also involved in the development of the rice policy. When before we have the policy way back in 2011, we mechanization of the agriculture sector, or at least in the rice sector for that matter, is quite low. But you see, the last 4 or 5 years, we move up the mechanization. We've been able to bring the best technology in the rice, in the rice mill. You have best Japanese machinery, that sort of thing. So I mean, and you see in the rural area, Kubota, this big
it's coming.
harvester, everything. So mechanization is there, but is mechanization synonymous to STEM also?
I think this is one part of it. Now I come back to STEM a bit, because science is a free thinking, innovations, discover the world, discover the universe, a big thing, right?
Yes.
I do not deny that we should not do this.
Yes.
We have to do this also, but this alone would not serve the societies. So there must be a balance between imaginations and what is your issue tomorrow in our society.
Yes.
I try to really link to real societies. You're talking about mechanization, agriculture. Recently I talk a lot about the fundamental for agriculture development. It's not only about land, not only about water. It's about science. In science, it's about biology.
Yes.
Yeah. Tissue culture.
Yeah.
Hydroponic. Those are the things, right? But do we have this kind of thing, right? So we're still thinking, okay, you have land, is okay. You have water, is okay. Extensive agriculture.
Yes.
We said that in rectangular strategies that we did that in 2010. 2010, I remember. R&D is the must.
Yes.
It's linked to all of this, right?
Yes.
But Cambodia, frankly, the problem is now at least we set the direction, we set the vision. Okay, this is where to go. It's good.
Yes.
Everybody talking about this now. Now the problem is implementation.
I think we're going to take a short break. When we come back, I want to tackle this very important issue of implementation. I think in the case of Cambodia, a lot of things relate to the lack or the weak implementation. Okay? Well, I mean, implementation, at the end of the day, you can have the best policy, but if the implementation is not there, the optimum result, outcome will not be there.
Right.
What you touch upon, it's quite interesting, and I see it's not just in the field of science, but perhaps we can just focus right now on this subject. What is your view on that?
Because I'm chairman of trustees of IUPP or University of Phnom Penh, I'm come down from policies to implementation.
Implementation.
And where I see the
Yes.
real problem is, you mentioned that quite long ago we emphasized too much on social science, marketing. It's true. There's no question about this. And after a while we changed that. Okay, we had to emphasize also on technology.
Yes.
And we agree on that, right? But how do we do that?
Yes.
How do we do that, right? I should not blame on the old day because there's no industry.
Yes.
No industry,
I agree.
right?
I agree.
Even you produce engineer, what you're going to do with
Yes.
engineer, right?
Yes.
An engineer who look at the astronomy, at the sky,
Yes.
what do we do then,
Yes.
right? We need it, but not answering to our need, right? But over the time, because of IDP, because our country developed, right, there are more industry here and there, so more people coming, and then I think we have to match together.
Yes.
For example, in my universities, 3 years ago, we established a new faculty called Faculty of Engineering, consists of 3 departments. This is real. IT,
Yeah.
biology, telecom, and electronic, right? So 3.
4.
But telecom and electronic together.
Okay, together. Yes. Yes.
3
Yes.
together. So now our students come to year 3, right? So where's the job, right? So this is real, right?
Yes.
They come. So now we're trying to link these people with Phnom Penh SEZ, Phnom Penh Special Economic Zone,
Yes.
so that they go to get some training, to get some networking with them, so that after they graduate they could find job. If after graduation they say, oh, teachers, I could not find my job, we could not promote it.
Yes.
Right? So everything has to link with demand and supply.
Yes.
This is not only about theory, not only about mathematics, this and that,
Yes.
but real, it's more kind of human effort. And our students, I must say that they are not really expert yet.
Yes.
But over time, at least, they start to learn little by little, and we also welcome advice from companies to teach us.
Yes.
Yeah, if our area is good enough or it's not good enough, which area we have to improve, so on and so forth. Recently, we've been talking also about the needs of other sectors, not only the 3 departments I'm talking about. Cambodia need what? Mechanics.
Yes.
Mechanical engineering, right?
Yeah.
Mechanical engineering and also electrical engineering. It's a basic thing.
Yeah.
If we learn from other countries, that are the things that it's a basic thing we have to have to develop our countries. So very, very down to earth.
Yes, yes.
Yeah.
It's quite interesting. Bang Thi?
Yeah, so implementation is important. I used to use this I call it 3M. In order to implement any strategy, any planning, you need man and the people, money, the funding, and the machine. So the agriculture is important, but there are many other fields of STEM that are needed in Cambodia. For example, just briefly, we want to to extract some oil, maritime Silk Road, working with China. You need marine science, you need a lot of other things. So to come back to agriculture, I like always to quote the late president of Israel, Shimon Peres. I met him at Davos at the World Economic Forum in 2010, and he's known to quote that agriculture, 90% science, 10% effort. So implementation is important. Number one, man people. We have people now. We have young, bright PhDs in agricultural science. I take just one example. At the Royal University Agriculture, at Preitlip Technological Institute, and you have the basic science IUPP. They can work together. And the problem that you have these people, but the ecosystem for R&D is not there yet. So number 2, you need the funding. So funding means governance and financing. So you need that policy of science, technology, and innovation coming from the government that need the direction. So you need people to select the grant. What are the priority for the country within the context IDP? Train the right people, get the right funding, invest for R&D. So that's about the money. And then the third one is machine and equipment. So it's about equipment in the lab that you need to be. A lab must be. Government must invest in lab, because private university will never invest that. The return investment is little. So it's the role of government to invest on heavy equipment for research, R&D, for engineering also, and also on the M machine. It's also the infrastructure for science technology. What do they mean by infrastructure for science technology? Is the connectivity between academia, university, TVET, with the industry, and with the STI institution, for example, National Science Foundation. So all this would be very important. The ecosystem has to be auspicious and conducive for these young brain that are here now. We have people in order to implement toward the direction that we need in order to use science and technology to boost the future of our economy.
You know, I have something to share that is quite surprising for me. It's quite a revelation also, because you mentioned about one-by-one road, you mentioned about engineering, that sort of thing. A few months ago, I was offered an honorary professorship with the Tianjin Sino-German University of Applied Science. When I went to their campus, it's quite interesting because their motto, this is something we could learn from other countries also.
Yes, yeah.
When China opened up 30 years ago, Germany came and worked out some arrangement to start. It was not a university when they started. It was more like a vocational
institute, yeah.
institute, you know, where they bring the private sector, Bosch, Siemens, all the big German company, right? And they set up the lab. The private company bring the equipment. You know, the Chinese bring their worker. Well, initially they got trained to work for German company. That's how Mercedes-Benz, Audi, everything is all assembled a car in China. But over the year, when they have enough supply, they open up for the larger population. But it's interesting, I wonder, you know, basically the company would send their staff to work to get trained in the lab there.
Right.
So in other words, when they go, you know, when students graduate, they know they have a job over there.
Right. Very practical.
And when they have a job, they can come back to study there. This is something, and they will come to Cambodia. That Tianjin University, they come to Cambodia. They will set up a campus here with the National Polytechnic Institute. Right? Yeah, and they will bring the machinery also, right? You know, I managed to get the 20 scholarship for high school graduate to study there. But I think the idea is that you mentioned something which is very important, which is the tripartite partnership, government, private sector, and you know,
public.
and the public there. See, so but back to the RUPP. You know, you have the school, but here the issue that Bong Thi mentioned is R&D. We have to be able to convince the government to allocate more funding for R&D, because let's face it, you know, nowadays Singapore, which is quite advanced, I mean, look at the amount of money they spend on R&D, for example. You have planned to?
We use a magical word called ecosystem.
Yes.
Right? Used to be in agriculture,
Yes.
but now become. So basically the environment has to be there
Yes.
in order to allow something to develop.
Yes.
So while talking about the foundation, the science foundation that the government just set, in other countries they have ministry.
Yes.
They have ministry, right?
Yeah. In Thailand, they have a
ministry
of Science
and technology, right?
yeah.
But we have all, at least we have foundation, right?
Yes.
But this alone would not. Okay, it's better not.
Yes.
Right? We need money, and then what? Right? It come real to universities.
Yes.
Right? To do what? What do we do with it? So we talk a lot about research, emphasizing R&D,
Yes.
R&D and R&D. But what do we do if there is no lab?
Yes.
What do we do with no incentive? So the whole system, ecosystem, had to be there. But on a positive note, I think over time, we know the problem. Well, we build bit by
Yes,
bit.
yes,
Now
yes.
money is available.
Yes.
How do we use it? Recently, we've been in talk with the World Bank.
Yes.
They come with something like $14 million for 4 universities in Cambodia. So they emphasize on this area, STEM plus A, agriculture, right? But you know, this is my personal view. I think that Cambodia, okay, we have a very great researcher or scientist like Wong, eh?
Yeah.
But in general, most of young people, they don't have experience in do research. Research for what?
Yes,
right?
yes.
It's not real, you know, research, you know, okay, maybe computer here and there, okay, research, right? But to me, as economist, I think research has to link with the need of your society.
Yes.
You have to link to the need of your society.
Yes.
And then you try to respond to the problem.
Yes.
For example, very simple, good example. We import tons of vegetables from Vietnam every day, right?
Yeah.
Can we do something about this? One answer would be technologies and hydroponic,
Yes,
right?
yes.
And tissue culture, right?
Yes.
Do we have this? We import orchid from Thailand every day, right? We could not do anything about this. Very basic thing. So
Yes.
I promote things that answering to the society's
Yeah.
need first. Yeah?
Yeah, I think we have to take a break. When we come back, we're gonna tackle that. But I want to look more in a larger context on where Cambodia fit in, not just in ASEAN, but in the larger world. And how do we emulate other country? Because you touch a very important point that, many things that we talk now, people think that research is just playing around with the computer. No, I think it starts at a much low level, basically primary education. And you always say that it's too late to love science when you are in the university. Yeah, have to start there. All right, so we'll take a short break. Well, I want to throw you just some statistic a bit, just to shock you. Is that China produced last year 4.7 million engineers, right? India 2.6, the US 568,000, Russia 561, Iran 335,000, Indonesia 206,000, Japan 195,000. Very low. So forget about us, okay? But what I'm saying is that, if China produced so much engineer, it means what? It means that 10 more years down the road, they'll be far more advanced, right? So let's go back to Cambodia. We have to think futuristically, right? If we want somebody who will work, as you said, in hydroponic, you mentioned about the engineering, that sort of thing. You have to start 10 years earlier. What's your view on that?
Yeah. Look, when we talk about R&D, we use an indicator to see where the country is. The two indicators mentioned to you is the amount of R&D invested, and number two is the number of scientists and technicians and engineers per million.
Yes.
So Israel has 8,000 per million, and then you have other countries, Korea, like 4,000 or 5,000. Lesotho at the top has maybe 10. Cambodia may have somewhere less than 100. So in order to do that, you need the men, you need the people, you need to increase this number of people working in that field. So the number of scientists and engineers per million must increase. That's number one.
Yeah.
Number two, who's going to pay for that? This is a big question here. For the training, you look at the German and Swiss model, for example, vocational training, 60% of the budget for training technician and engineer come from the private sector because the industry benefit from that.
Yes.
And the number of unemployment in youth is very low in those countries compared to Portugal, France, Greece that go from 25 to 50% because the vocational training is not there. So that's for the training. And then the research, we need a structure for that. Who's going to allocate to that research? So if Cambodia can move, I think we're moving toward that direction.
Yes.
Because people we have, IUA,
Yes.
IUPP, they have people
Well,
for that.
the Minister of Education, Youth and Sport, Dr. Naron, have a very clear view on how he sees STEM. I think since he became minister, I think he did bring a lot of vigor into that scientific field, and he started to have a clear policy orientation, even to the point that he felt that you even have to move up the quality of the professor first before you can look at the student.
Yes, it is implementation issue again.
Yes.
But I'm optimistic that now we keep talking about this. We set a direction. Everybody know the problem.
Yes.
We're trying to change it bit by bit. quality of professors, quality. We could not get, okay, I make quality professor first and then I teach, right?
Yeah.
You have to do it at the same time.
Yeah.
You have to do it at the same time.
Yeah.
So sometimes we have professors who are old, right?
Yes.
Who are old style, but we could not ignore them.
Yes,
right?
yes.
We have to work with them. I think have to go in parallel.
Yes.
Yeah. Old style, we keep old style, but introducing new ideas, and the new one will change the system. I believe in that. I don't know about other universities, but my universities produce 150 engineers a year.
Oh.
not 1,000, but
Okay.
at least one. But
It's better than 15.
but I'm not so worried about
Yeah.
the number. I think if we could do something that answer to demand, right?
Yeah.
We don't want to produce something that we could not find a job, for example, right? As I
Okay.
mentioned, right?
Yes.
So demand and supply, we have to link, as I mentioned earlier,
Yes.
that the private sector have to come together, not only to recruit our people, but
Yes.
also advise us.
Yes.
What kind of education you need in futures. Now clearly they advise you need mechanical engineering, you need electrical engineering, very basic thing. In the futures, what going to happen, I understand broadly, but realistically we have to answer the question on the field. And as I mentioned, that money is a problem, system is a problem, incentive is a problem. We have so many regulations when running universities. We have money to do research. We know what we want to do, but there's no procedure to do that.
Okay.
Why that?
So it's an institutional issue.
Institutional issue. Why that is? Because it's a ministry not clear on this, on this, on this. We worry about auditing when it comes to audit us.
Okay.
We're in trouble. There's so many things that have to change from the system. So I think at least the will is there.
Yeah.
The good news, the will is there.
Yes.
But we change the system, change the
Yes.
institutions, and money is there. Money alone is not enough. Who going to do that?
Yes.
Capable or not? Committed or not? Right?
Yes,
Yeah,
exactly.
and otherwise, very famous story that researcher tend to be that if not committed researcher, you just spend money.
Yes, exactly.
Yeah, there are 3 points to this. Number one, certainly the current Minister of Education pushed a lot of STEM, and it's very laudable.
Yeah.
And we found out that a graduate from many universities in the region lack the entrepreneurship skills. So entrepreneurship education, which is part of North American or in Shenzhen, for example, must be taught. That's number one. Number two, I just came back from Shenzhen. I have the honor to be appointed as a international advisory on advisory board of the International Center for Higher Education Innovation Shenzhen, supported by UNESCO. And the point that we discussed was the quality assurance higher education, and the key point that if you want to have the quality, you have to fix the teachers.
Yeah.
So faculty member development is important.
Accreditation of the university is very important also.
Absolutely. Yeah. So so training in STEM is good, and STEM is not a subject. Cambodia, in the curriculum, high school, university, we teach chemistry, physics, math for decades. But STEM is not the teaching. It's not a subject. It's the integration of all this together, so that the graduate can solve a complex problem like climate change, traffic jam in Phnom Penh, urban development, pollution and the workplace, etc. So, and science and technology, you need also the culture. People seem to say that science and technology is not my business, and top policymakers in many countries fear science and technology. For example, at the Ministry of Foreign Affairs, science and technology is eminently important when you go to negotiate climate change, trade, pandemics, terrorism. All that is about science and technology. And without that, when you sit at the table, you have no clue.
Just give an idea that now war is all about war, but soon war will be all about water, for example, and it's linked to climate change. It's migration is linked, terrorism is linked to migration. So many things are interconnected, and I think there are professionals that we call futurists, where they say, okay, with science evidence, scientific evidence, they show mapping, satellite mapping over a time period, and they see that, look, this area used to be like this, 5 years, 10 years, 20 years later, it become like this, and because of this deforestation or because of this dryness, whatever, it's called the sand dune moving in, desertification, and that's why you have all this migration. So science is basically the answer to so many things that we visually cannot just imagine.
And there's a trend now in international relations to push science at the top of the agenda. It's called science diplomacy. The IEA is a science diplomacy agency for that. It's very important. CDIB, I was able to convince a STEM expert from Darwin University from Australia to spend 1 year with us, pro bono. You know. The first question he asked me, he asked, Director, I'd like to meet the CSA, Chief Scientific Advisor. And I say there are no CSA in Cambodia. In every developed country, the president or prime minister has a chief scientific advisor to advise on this very important matter, working closely with the industry, with academia, and with the science technology innovation team. You know? So that's very important. The context is important. The workers important, at the ground researcher, and money is important.
You know, we almost at the end of the show, but I want to sort of like put the whole thing we discussed a bit in a historical context a bit, right? You know, we all know that 20-some years ago we just start from scratch. In 20-some years we come a long way. We're nowhere near, you know, other country, but starting from such a low base, we've been able, you know, I think it's sort of like we grope around, trial and error. We achieve what we could achieve in the time spent, and it's quite interesting that everything is all relative. I remember in the early 90s when I was lecturing, you know, one class, and I asked, at that time was the National Institute of Management, now it become National University Management. So I asked the class, I say, how many of you would like, when you graduate, to work, you know, in the private sector? There was two very hesitant,
Timid
you know,
guy,
and then, wow, how many people would, you know, join the, you know, the public service? Everybody raised their hand. I was shocked. I didn't know the answer. Years later, you know, the same thing now. I asked the same question. It's the actual opposite.
Okay.
And it's interesting because in those days, back in the early 90s, what private sector?
What engineer?
What engineer? What business? What entrepreneurship? Right? So you see, we have evolved.
Right.
You know, and irrespective on how frustrated we are on the pace of the scientific change, we have seen that the country progressed. And to be fair, when we joined the WTO, we opened up the education sector. We want to introduce a clear accreditation process, and then because of this opening, private sector university just blossom. But then what do they, you know, bring in terms of education? The easy one, where they don't have to invest. A building, some teacher, some table,
PowerPoint.
if they have slide, it's the best already, right? You know, I hear on the radio people advertise that their school have projector. I mean, advertising. So in those days, right? But now we see, look, in the last several years, since we have the IDP, right? We start to see, you know, student people shifting to, you know, education that bring them job. So I would say in that context, I think we just need to push more the message.
Right,
and this dialogue is very important because we let them know that, look, the future, the fourth industrial revolution, the industry 4.0 is all out there. But guys, let's start. You're doing good at 150 a year. Hopefully next year at 300.
Better, yeah.
But I will shock you by telling that now there is a company, private sector, who employed over 100 software engineers, young software engineers. Many of them are graduated from IUPP and ITC. 5 years ago, it's unthinkable.
Right.
When he took me to his office, I was shocked.
Right.
So anyway, I think that's how I see the evolution of the STEM, right? It was there, but we didn't know what it is. Now getting more and more focused. So I'll give you the closing remark.
I totally agree with you that we must be happy with the past has been done, but we have to be concerned about the futures also, where we go from now.
Yes.
But over the time we're talking together like this, we define the target, we define the issue. Everybody knows that STEM is important, right?
Yes.
But as I say, how do you do that, right? And realistically, right? You don't want to produce 1,000 and then there's no job, right?
Yes.
This is the reality. I think over time I'm optimistic that we could move forward as long as we keep talking. I think so many foreigners say that, oh, Cambodia is quite open societies because we are conducive, we listen to advice, right? And we try to do things that is good for us.
Yeah.
We are not stubborn.
Yeah, yeah.
We know how to survive. Right? I think I'm optimistic about the futures.
Yeah. I think the STEM policy come from the government, but if you wish to train a workforce to develop economy Cambodia, you need a commitment for all
The
stakeholders.
stakeholder, yeah.
All stakeholders. The industry must contribute to the training of technologists and engineers.
Yes.
Also. The family. At one point, a parent should stop telling their kid that don't study science to become a teacher. This is a myth and
Or to become a mechanic.
Mechanics, you know, it's prestigious to study science. It's prestigious to study engineering. And if you provide them with entrepreneurship, they will create a job for themselves. But after all, so science technology for me as a STEM, I'm coming from a family of STEM. My career is about STEM. I believe in science and technology, but at the end of the day, it's just a tool for economic development. And I will conclude that we must add that arts, because you have the human dimension to deal with that. Look at the case of a nuclear disaster of Fukushima, which I dealt very closely on the science technology impact on environment and livelihood. The human dimension is still the fundamental of all education system for a country.
Another A, not agriculture A,
Yes.
but arts A.
Arts, yeah.
But and I will wrap up by saying that Cambodia very, very artistic in that sense. All right. Well, all the three doctor here, I have to congratulate you and to thank you for coming to share our perspective. Okay. And I think this is something that we should every so often to come in just to share and just to stimulate a bit more the debate, the discussion. 45 minutes is not much, but I think it's important that the young population start to realize that the future, their future, you know, is also linked very much to the future of our nation, to this, I don't want to use the word survival, but to the competitiveness of Cambodia. We are part of a very dynamic sub-region, you know, ASEAN. I don't want to say the whole ASEAN because you have the ASEAN landmass and the, you know, maritime ASEAN. But if we just focus on the Mekong sub-region itself, you know, we're competing with Vietnam, who's producing 100,000 engineers a year. We are competing with, I don't want to use the word competing, we have a neighbor in Thailand who have all the car manufacturing assembly there. You know, Myanmar is rising fast. So we are in a dynamic region. We cannot be complacent. You know? I'm glad you say that we're very open-minded, but, you know, let's focus on what we can do more now in terms of policy, in terms of implementation, in terms of stimulating our younger population to love science, to love STEM, to love STEAM, and to love style. So on that note, thank you so much, and I'll see you next time.
Thank you.
All right, I'm not gonna bother wrapping up. I think we did a great job already to stimulate the discussion. You know, we start with STEM and then then STEAM, then STY. I think now we have to stop. All right, good night.